And if for some reason, guys, you're really going to want to pay attention to this. This is going to be tough stuff that we're working on for the next few days. Okay? If for some reason you don't have notes, you can just copy these examples down on a sheet of paper. Okay, there's really nothing special about this handout other than it's got the problems written on it for you already. Okay, here's what we're talking about today. We've already talked about solving systems by graphing, right? Where we draw the graph and we find the point where they intersect. Yeah. We're still doing that, but I don't want to draw a graph every time, and I bet you don't want to either. So today we're going to talk about an algebraic way to find that solution point. Okay? So a way that does not involve graphing, but I just want you to understand when you get your answer, that's what you've really found, is where those two lines would cross. This is one way to do it. This is called substitution. We're going to learn this today and practice this today and tomorrow. Then you're going to learn another new one on Monday, a different way to do it called elimination that you're going to practice. And then we're just going to practice kind of mixed. You know, we're going to practice it where you're doing it this way, you're doing it that way. You're going to get to decide which way you want to do it. Next week, Friday, you do have a quiz over solving these systems. And on that quiz, there's going to be some that say you have to do substitution, some that say you have to do elimination, because I want to see that you can do both methods, and then some where you get to pick whichever method you like better. By the time we roll around to your chapter test, I'm just going to give you a system and say, here, solve it. And then I don't care which method you use, okay? So try to learn both of them, but most people tend to sort of gravitate to one or the other that they like better, and that's going to be okay by the time we get to the test. Isaac, you with me back there? Okay. Okay. So the key to doing substitution is to get one of your equations to have one of the variables by itself. Doesn't matter which equation, doesn't have to be both of them. Sometimes it is, but it doesn't have to be both. And it doesn't have to be y. I know you're used to getting y by itself for slope-intercept form, and so that's what people always want to do. But if you can get x by itself, that's fine too. That will also work.
So this is the first way, right?
This is the first way. Well, the first way besides graphing. So we've already talked about graphing, but this is the first, like, algebraic way to do it.
You use two algebraic ways to do it?
Mm-hmm. Yep, that's right. Yeah, if you flip to, like, the next page in your packet, you'll see solving by elimination. Those will be your next ones. Okay? All right. So do you see in this first example how I already have this equation with y by itself? It says y equals blah, blah, blah. That's good. That means I don't have to do any work to get this set up. I can just start solving. Okay? Sometimes you're not going to have that, and you'll have to rearrange the equation to get y by itself. Okay? But this is already set for you. So here's what the point of this is. If I'm saying y equals x minus 3, really what I'm saying is y is the same thing as x minus 3. Okay? So up in that top equation, if y is the same thing as x minus 3, they're interchangeable. And I can take that x minus 3 and put it in place of y up here. Because they're the same thing, right? I can substitute things that are exactly the same. So here's what that will look like. That top equation would now say 3x plus, but instead of that y, I'm going to put x minus 3 equals 25. Why would I want to do that? What's good about this equation that I have here?
You have two x's.
I have x's now and no y's. Now I can just solve this. Now this is just an equation to solve. What would I do to solve that?
Combine.
Okay, so I would probably combine the 3x and the x to make 4x. Remember that if your x's are on the same side of the equals, you can just combine them. You don't have to add to both sides. You can just combine. So that's going to be 4x minus 3 equals 25. Yep. Let's add the 3. So 4x equals 28. Divide by the 4. X equals 7. So from there, probably not so bad, right? You've done all that before. Now here's the thing. That's your x coordinate. Our answer needs an x coordinate and a y coordinate. So we've got half of our answer, but the second half is really not hard. Okay? If you've got x equals 7, right here it tells me that y equals x minus 3. So I'm going to take that 7 and just plug it right back in there and make it y equals 7 minus 3. So I plug that in for x. So what does y equal? 4. So my final coordinate would be 7, comma 4. Good. Good. Now do remember that that one was kind of already set up in a real nice way for you. They're not always like that. Okay? And actually I wish I would have made some of my examples a little harder, but that's okay. They'll make do. Alright, so let's try the next one. Do I have something by itself in the next one? Yeah, I actually have two somethings, right? Y is by itself in both equations. That's okay too. You really only need it in one, but it can be in both. So I'm going to take one of them, and I'll just do this one again to stay consistent. I'm going to say, okay, y is the same thing as x plus 4. So I'm going to take that x plus 4 and put it in for y right here. Okay? So now my equation would say x plus 4 equals 3x. Okay?
So what's the substitution part?
That I'm substituting this in for y.
Oh, okay.
Okay, that I'm substituting what y equals in one equation into the other equation. Okay, if you do it correctly, you should always end up with an equation that only has x's or only has y's. If you substitute and you still have both variables, you mess something up. How would I solve this from here?
You do plus
Minus the x. So 4 equals 2x, then divide by 2. So x equals 2. Now I can take that 2 and plug it back into either one of my equations because they both say y equals blah, blah, blah. If I'm trying to find out what y equals, I want to look for an equation that says y equals da, 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 da. So if I plug that 2 into my first equation, what do I get for y? Yep, 3 times 2, so y would be 6. Would I get that same thing if I had put it in the second equation?
Yep.
Yeah, so that means that I'm right, okay? If you had done that and it would have come out to 2 different numbers, then somehow you messed up in that first part and that your x value would be wrong. So final coordinate would be 2 comma 6. Okay? All right, let's try the third one. What's the problem with the third one starting out?
There's X and Y on
Yeah, you don't have anything by itself, right? So we're going to have to do some work ahead of time for this one. But what looks like it would be pretty easy to get by itself? That first one, the y, right? I could just move the 2x to the other side. So I'm going to subtract 2x and subtract 2x. And now this equation is really going to say y equals negative 2x minus 1. That piece of it you guys have been doing forever. James?
How did you get to 6?
Oh, up here?
Yeah, I have negative 2 too.
Okay, I got x equals positive 2 here. Whoops, sorry, you can't see. Okay, I got x equals positive 2 here. I subtracted an x from each side.
Hold on. Oh, I see where I messed up.
Do you? Okay. Okay, so back to this one. I've got y by itself now. So now I know that y equals negative 2x minus 1. So that's what I'm going to take and put in here for y. Now this one's a little weirder because the y is kind of embedded in an equation, but that's okay. I'm just going to recopy this equation exactly, but when I get to the y, I'm going to take it out and replace it with that. So negative 3x plus 3, and then in parentheses, because if you're putting something in where there's already a number, you've got to put it in parentheses. Negative 2x minus 1.
Why do you have to put it in parentheses?
Well, because this said 3 times y. If y is all of this, then when I put it in here, I need to make sure I'm doing 3 times all of that.
Oh, because if
Okay.
you didn't put the parentheses, it would be 3 times negative.
Exactly. Yeah, you wouldn't be multiplying the whole thing by 3. Okay? So if you're taking something this big and substituting it in for something this big, you've got to put it in parentheses to show that it's like all one thing. Okay?
Alright.
From here, let's distribute. So negative 3x plus, that's going to be negative 6x, and then 3 times negative 1 is negative 3. equals negative 21. Here your x's are on both sides, so I don't want to see anybody saying plus 6x plus 6x. We're just combining and making negative 9x minus 3 equals negative 21. Let's add the 3 to each side. Negative 9x equals negative 18. Divide by negative 9. X equals 2. Now I'm going to plug back in to find y. I can plug it into either one of my original equations, but wouldn't I rather plug in someplace that says what y equals, if that's what I'm trying to find, is what y equals?
Yeah.
So I'm going to plug it back into this equation that I rearranged. I'm going to plug it in right there. And that's okay too. So you can plug it in here or here or here. Just if you put it in one of those, you would end up having to solve for y, whereas this already has y by itself. So that's going to be your easiest way to go. So I would say y equals negative 2 times 2 minus 1. Okay. That's negative 4 minus 1, which is negative 5. Okay. And so then my coordinates would be 2, negative 5. Good? What about that last one? Do I already have something by itself?
Yeah, why?
I do. This one is one that probably if it were to pop up on your homework assignment, everyone would raise their hand and say they have no idea what to do and they need help, when it's one of the easiest ones you're going to see. Okay? It's really not that bad. If y equals 8, then 8 is what I'm substituting in for y down here. Okay? So I'm going to get 2x plus 5 times 8 equals 8, which means 2x plus 40
I know this.
equals 8. Where do I go from here?
X equals 0 because that plus 8 would equal 8.
Not quite, because that's 5 times 8 though. I see what you're thinking. I see, if this had just been 8, if it was just 2x plus 8 equals 8, then yes, that would be 0. But because it's 5 times 8, that's really a 40. What do I do with the 40? There you go, minus the 40.
No, I don't.
So 2x equals negative 32. Divide by the 2. X equals negative 16. Where do I plug that back in to find y?
But you already have one.
I already have y. Good. Alright? They told me that y is 8. Y has to be 8. If I plug this 16 up there, this says y has to be 8 no matter what x is. Okay? So my coordinate is just negative 16, 8. How you feeling about those?
That's legit.
Legit. Okay, good.